Okay, we'll do minimization of DFA. If you remember, the first step is in minimization of DFA is to identify the inaccessible and dead states. Okay, just if there are any inaccessible states, we can remove it, and if there are any dead states, we can remove it. Do we have any inaccessible states here? If so, which state is inaccessible? Can I have it on the chat box, please? Do we have any inaccessible state? If so, which state is inaccessible? Two, five. Okay. Which state is inaccessible? Okay. Do we have any dead state? Do we have any dead state? If so, which state is it? Do we have any dead state? If so, which state is it? At least give an yes or no answer for the dead state. Do we have any dead state? Okay, I'll give you the last option. Is Q5 inaccessible or a dead state? If it is inaccessible, give the answer as 1. If Q5 is a dead state, give the answer as 2. Fine, the state is inaccessible. It's not inaccessible state, Anguma. The state is a dead state. Okay, Q5 is a dead state. 1 second. So there are no inaccessible states as such, but then the dead states are, you have only one dead state, and that is Q5. So what we'll do is we'll automatically remove all the transitions of the state Q5. So for our easy conversion, we'll try to convert this into a tabular format. We'll convert it into a tabular format. So you have transitions on 0 and 1 from Q0. On 0, it moves to Q3. On 1, it moves to Q1. Okay, from Q1, on 0, it moves to Q2. There is a equal to, we'll just avoid it. And on 1, it moves to Q5. Now I have eliminated Q5, and they will include Q5, then we'll try to delete it. Okay, and then we'll move from Q2. Q2, on 0, it moves to Q2. On 1, it moves to Q5. What about Q3? Q3, on 0, it moves to Q0. And on 1, it moves to Q4. Okay, what about Q4? Q4 on 0 is to Q2, and on 1 it is to Q5. So Q4 on 0 it is to Q2, and on 1 it is to Q5. We have one more state to go. Q5 on 0 and 1 is Q5 itself. Q5 on 0 and 1, it is Q5 itself. Fine. So this is what we have. Now what am I supposed to do? Remove all the inaccessible and the dead states. Fine. What am I supposed to do? We'll remove all the inaccessible and the dead states. We don't have any dead states. sorry, inaccessible states, we'll just remove the uh, state alone. So we'll let state alone, and therefore q naught is also removed. Q5 is also removed. Now, among which Q1, Q2, and Q4 are Q1, Q2, and Q4 are final states. Q0 is an initial state. Q0 is an initial state. The rest are Q3 is a non-final state. So what is the next step? Next step is to group them into final and non-final states. So Q naught, we'll have Q naught and Q3 in one set, Q1, Q2, and Q4 in the other set. Okay. Now what about Q naught and Q3? Q naught on 0 it moves to set 1, that is this group. Q naught on 0 it moves to Q3, which is in the same group. Q3 on Q0 also moves there. Both states on 1 moves to a different group. Now tell me whether Q naught Q3 is distinguishable or indistinguishable. Tell me whether Q naught Q3 is distinguishable or indistinguishable states. Okay. So now what are we going to do? We'll take initial state and all the non-final states into one group, which means initial and all the intermediate states into one group. The final states will be put in another group. So the easy way of doing it is put the final in one group, combine all other states in the other group. Now the next step, you have one group has two states, other group has three states. Now take the transition of 0 from Q0. Q0 on 0 moves to Q3, which is there in group 1. Okay, Q3 on 0 also moves to Q0, which is again there in group 1. Okay, but then what about transitions on 1? Q naught moves to Q1, which is in, if I take this set as group 2, Q naught on 1 moves to group 2. We'll talk in terms of group and not in terms of states. Okay, Q3 on 1 moves to group 2. So they move on to a same set of groups. On different outputs, they move on different input symbols, they move on to a same set of groups. Fine. If that is the case, they are termed as indistinguishable states. Fine. They are termed as indistinguishable states. Fine. They are termed as indistinguishable states. You cannot separate them. Now, what about Q1, Q2, and Q4? Q1 on 0 moves to Q2, it moves to the same one group, group 2. Q2 on 0 moves to Q2. Q4 on 0 also move to Q2. Now, what about 1 and 4? 1 and on 1, you don't have transitions at all. So, tell me whether Q1, Q2, and Q4 are distinguishable or indistinguishable. We'll have a poll. Now, you need not do anything and put it onto the chat box. We'll just have a poll saying whether it is distinguishable or indistinguishable. You can answer the questions, answer the poll. We'll end the poll and I'll give attendance to only 19 students. Okay, I'm closing the poll. Okay, now what is it? It is indistinguishable because both of them moves on to the same group. So what we'll do is we'll make it as Q03, Q03. Why? Because both Q0 and Q3 are indistinguishable. So we'll combine it into one single state. And the other one is Q124 because I have combined all the three states into one single state. Fine. Now I'll redraw or rewrite this transition table. How will I rewrite it? Wherever I have Q0 and Q3, I'll make it as Q03. Okay, and wherever I have Q1 to 1, 2, and 4, I'll make it as Q1 to 4. If you see here, this is the statement, this is the table what you get after converting Q0, Q3 to Q03 and Q1, Q2 and Q4 to Q124. Now what happens? This becomes a duplicate. So this I can all delete it. These two also becomes duplicate because these two can be deleted. Now what we'll do is we'll draw a diagram for the minimize DFA. So easy way of doing it. We have only two states now. The first state we'll rename it as Q03, and the second state we'll name it as Q124. And now this becomes an initial state. This becomes the final state. Right from Q03 on 0, it moves to itself, and on 1, it moves to the next state Q124. On 1, it moves to Q124 itself. So this becomes here minimize DFA. Fine, this is how you get a minimize DFA. Any doubts in the first part? Can we move on to the next question? Any doubts here? Can we move on to the next one? Should I repeat anything? Okay, we'll move on to the next one. We have next question here. Now the question is, which states act as dead state? Which are the states which act as dead state? 1 second. These are the same diagram, is it? Yeah. We'll move on to this one. Which states do we have any inaccessible state or and dead state? Do we have inaccessible state or dead state? Do we have any inaccessible states or do we have any dead states? Okay. Okay, we don't have any inaccessible states. We also don't have any dead states. So we'll try to convert them for an easy way of translation. We'll try to convert them into an table format. Fine. So you have states Q0, Q1, Q2, Q3, and Q4. Now, what are the input symbols? Input symbols are A and B. Now, from Q0, you move on to Q3, and on A, you move on to Q1, right? Now, from Q1, on A, we move on to Q4. On B, we move to Q2. From Q2, let us start. From Q2, on A, we move on to Q4. On B, we move on to Q1. Then on Q3, Q3 on A moves to Q4. And on B, it moves to Q2, right? And the last one, Q4 on A and B, it moves to Q4, right? So, can I have the first level of grouping? We don't have any inaccessible state. Also, we don't have any dead state. So, which is the final state? Final state is Q4. And which one is the initial state? Initial state is Q0, right? Now, which states can be grouped together? Can I have the first level of grouping in the chat box, please? Can I have the first level of grouping for the given question? Which states will be grouped together? You do convert it into or group it into final and non-final states. Can I have the answers, please? Fine, I think Q4 is the final state. Okay, you have 4 or 5 answers onto the screen. We'll move forward. Q4 and Q3 will not be together, ma. Q4 is the final state, and Q4 and Q3 will not be together. Q0, Q1, Q3 goes together, whereas Q4 is the final state. So we'll move forward. We'll go ahead with Q0, Q1, Q2, and Q3 in one group, and Q4 in the next group. So we cannot do anything with the second group, whereas I can do something with the first group, right? You can do something with the first group. We'll do it. We'll do it one by one. Now what happens? Q0 on A moves to Q3, whereas Q1, Q2, Q3 on 0 moves to Q4, a new set. So now tell me what will be the output of this state? Among Q0, Q1, Q2, and Q3, which are the states you think that are indistinguishable? Do you think all 4 states are indistinguishable? Or do you think there are few states which are indistinguishable? Can you put it onto the chat box, please? Among Q0 to Q3, which are the states you identify them as indistinguishable states? Among the given group, which states are indistinguishable? Is it Q0, Q1, Q2, Q3 all together are indistinguishable, or Q0, Q1, Q2, Q3, or it is Q0, Q1 in one set and Q2, Q3 in the other set? Option number 1 is Q1, Q2, Q3 are indistinguishable. Option number 2 is Q1 and Q3 are indistinguishable, whereas Q0 and Q2 are different, are there in different groups. Okay. Q0, we have the answers. Q0, Q1, Q2, Q3 are indistinguishable. Do we have any other answers? No, fine. Thank you, ma'am. So we'll say Q1, Q2, Q3 are indistinguishable. So I'll put Q0 in a single group, Q1, Q2, Q3 in another group, and Q4 is already in a separate group. Okay. Now, among Q1, Q2, Q3, can any changes be made? Can we make any changes among Q1, Q2, and Q3? Can I further distinguish or separate Q1, Q2, and Q3? Can I have the answers onto the chat box, please? Okay, you cannot further separate it, right? So what are we supposed to do? We'll now go for minimization part. So among which Q1, Q2, Q3 can be put together. So how will I represent it? I'll represent it in this way. Q0 is one set, Q1, 2, 3 belongs to the next group, and Q4 belongs to the last group. So Q0, Q1, 2, 3, wherever Q1, 2, and 3 comes, we'll go give it as Q1, 2, 3. Q4 remains as such, and Q2 becomes Q1, 2, 3. This becomes the last one is Q1, 2, 3. Here it is Q1, 2, 3, and here it is Q1, 2, 3. Now what has happened? These three are duplicates. So we'll just remove it. So you have now three states. The three states, we'll go ahead with the next transition. We'll say we'll have three states. So Q0, Q1, and Q4. We'll just rename it. Q1, I'll make it as Q1, 2, 3. Just for our easy understanding, fine? And Q4, we'll make it Q2, we'll make it as Q4. Which one is the final state? Final state is here Q4. Q0 becomes the initial state. From Q0 on A and B, it moves to, sorry, on A and B, it moves to Q1, 2, 3. Q1, 2, 3 on A, it moves to Q4. Q1, 2, 3 on B, it moves to itself. Okay, and Q4 on A and B, it moves to itself. And so this becomes the minimized DFA. And so this is how you will work on with the minimized DFA. Now we'll move on to any doubts on minimization of DFA? Any doubts on minimization of DFA? Okay, now answer me few questions. When I can, if I can reach a state Q3 from the inaccessible state, but I cannot move forward to the final state. Okay, I'll repeat the question. In case I am able to reach a state Q3 from the initial state Q0, but from Q3 I have no way to reach the final state. What is the name of the state Q3? Okay, dead state or trap state. Okay, we'll from Q2. Okay, from Q2. Thank you, Ma. Thank you for your responses. From Q2, I am able to reach the final state. But then from Q0, I will the Q0, the initial state, I will not be able to reach Q2 at all. What type of state Q2 is? It is inaccessible state. So what is the first step? First step is to group them into dead state and inaccessible state. Now, why do I want to minimize the number of DFA states? There are two reasons behind minimizing the number of DFA states. Why do I need to minimize the number of DFA states? Why should I reduce the number of DFA states? Any guess from your end? Put it onto the chat box, please. Why should we reduce the number of DFA states? Okay. The first one is to traffic congestion. Steve, the first one is to minimize the storage overhead. And the second one is to improve or increase the processing time. Fine. So these are the advantages while you minimize the number of DFA state. The first one is to minimize the storage overhead. The second one, as and when you reduce the number of DFA state, you will be able to increase the processing time in certain cases. Fine. So we are going traffic congestion. This is not networks, Thambi. This is purely TOC. We'll go in technical terms. Okay, to minimize the storage overhead and to increase the processing time. Now we'll move on to recollect how you converted an DNFA state to an NFA to an DFA. Fine. The first one is to identify the initial state of NFA, right? So what are we supposed to do? Which one is the initial state of DFA? Which one is the initial state of DFA? Q naught is the initial state of DFA. So we'll move forward. The initial state of NFA will act as the initial state of DFA. So we'll say delta star of Q0, comma, the transitions are on A and on the transitions are on B. The transitions will be on A as well as the transitions will be on B. Fine. Now, tell me what is the output of delta closure of Q naught A comma B? Sorry, Q naught on A. What is the transition output of delta closure of Q naught on A? We'll have poles here. I'll just stop sharing. We'll go in for the polls. Now you can answer the question. Fine, you have 17 people who have voted. I'll just end the poll. I'll end the poll with half the head classes responses. You have Q naught, all options are given. Q naught on A is Q naught alone. Okay, we'll go ahead with the answer now. Q naught on A, you have three transitions. Q naught on A, it moves to Q naught. So I'll include Q naught. Q naught on A, it also moves to Q1. So we'll include Q1. Q naught on A, it moves to Q2. So you have three outputs on A. Q naught on A, it moves to Q naught. Q naught on A, am I sharing the screen? Okay, Q naught on A, it moves to Q naught. On A, it moves to Q1. On A, it moves to Q2. So you have three states as output. So the next new state will be Q naught, Q1, Q2. What about Q naught on B? Q naught on B is a null set. You don't have any transitions on B. So the next one is your delta closure of Q naught, Q1, Q2. Sorry, you're supposed to give it within set notation. Find this again, we'll put it in set notation. On A. Now Q naught on A itself gives you the complete set. Okay. So we'll just go ahead with Q naught on A is Q naught, Q1, Q2. Find the complete set. Now what about Q naught on Q1 on A? Q1 on A, you don't have any transitions. Q2 on A also, you don't have any transitions. We'll stop here. What is delta star of Q1, Q2, Q0, Q1, Q2 on B? What is delta closure of Q0, Q1, Q2 on B? Can I have the answers, please? Onto the chat box. Can I have the transition outputs for Q0, Q1, Q2 on B? Your answers, it's Q1. The reason is from Q2 it moves to Q1 on B. From Q1 it moves to Q1 on B. So you have the output as Q1. Right now, to which state I should find out? You have found transitions of Q naught on A. We have found transitions of Q not Q1, Q2 on A and B. Now I am supposed to find transitions for Q1 on A as well as Q1 on B. Now, what is Q1 on A? You don't have a transition at all. So this becomes a null set. Now, what about Q1 on B? Q1 on B is Q1 itself. Fine. So there are no new states to be created. So what am I supposed to do next? We are supposed to create a table which represents all these transitions. How many states do I have? I have three states, Q0, Q1, Q2, Q. So we have the first state as Q0, second state will be Q0, comma Q1, comma Q2. And the third state is Q1. Now tell me which are all the final states. Which are all the final states you have here? Among the three states of DFA, which acts as which are all the final states? Okay, you have two final states because Q1 is the final state here. Whichever state has got Q1 will act as a final state. So you have two states which acts as the final state. Now we'll go on filling the transition table. Q0 on A is Q0, Q1. This is on A and this is on B. Now, what about Q0 on B? It's a null set. What about Q0, Q1, Q2 on A? You have Q0, Q1, Q2. And the next one is Q1, alone. Now again Q1 on A is null set, Q1 on B is Q1 itself. Fine. For which we'll draw the DFA diagram. Now tell me, can I minimize any state over here? You have three states. Q naught is one state, Q naught, Q1, Q2 is another state, and Q1 is another state. Can I do an minimization here? Yes or no? Tell me whether minimization is possible. Tell me whether minimization is possible on the given transition table. Yes or no onto the chat box, please. Okay, you cannot, it is not possible because Q naught is an initial state. Thank you, ma'am. Q naught is an initial state. Q1, these two states will be pulled together, but then the transitions are entirely different. Fine, here you don't have a transition at all, and therefore no combination is possible. We have to go for the NFA. So whatever you have obtained is the minimized DFA. Sometimes when you convert an NFA to DFA, the result would be a minimized DFA. Fine. Sometimes you will never get a minimized DFA. You are supposed to further minimize it. So you have two options. Sometimes while you solve it, whatever you get is a minimized DFA. Sometimes you will never get a minimized DFA. You are supposed to move for the apply the minimization procedure. And so whenever you get a result, ensure that you make a check to find out whether what you have obtained is a minimized DFA. So you have three states again. This will make it as the initial state. This will rename it as Q012. I'll rename it in the Q012 just to represent the next one. This will name it as Q1. And Q1012 is the final state. Q1 is also another final state. From Q0 on A, on A it moves to Q012. Q012 on A it moves to itself. And on B it moves to Q1. Again it moves to Q1 on B. Fine. So this becomes your NFA. Now we have one more thing to go. We'll try to understand it. Right? Now I have a different representation. So for all the examples what you have taken will be either Q0, Q1 or Q2. Now I have a complete different representation saying 1, 2, 3. Any state can be either represented as Q0, Q1, Q2, Q3, or it can be represented as 1, 2, 3, or it can be represented as capital ABC. Fine. All these representations are allowed. Okay, so far we were used to Q0, Q1, Q2, Q3. Even if it is P0, P1, P2, P3, it is allowed. Okay, and then if there is an option of Q1, 2, 3, that is also allowed. So we'll move forward. Which one is the initial state? Set with value 1 is the initial state. So we'll just go ahead saying the delta star of or delta closure of 1 on A and delta closure of 1 on B. What is delta closure of 1 on A? 1 on A, it moves to 1. 1 on A, you have a transition to 2. 1 on A, you also can have a transition to 4. Fine. So you have 1, 2, and 4 based on delta closure of 1 on A. How did I get it? A self loop on 1 on A to 1 itself. So I have included 1. A lambda or A epsilon moves on to 2. So I have included 2. A epsilon, any number of epsilons can be prefixed or suffixed, and therefore 4 also comes into picture. You have 1, 2. And then what about the next one? From 1 you have a direct A to 4. So you have 1, 2 and 4. And then 1 on B. I don't have a transition directly on B. So B lambda or B epsilon is ruled out. But then I have a transition from 1 to 2 on epsilon. So I'll check whether I have transitions on epsilon B. If you see here, epsilon B reaches uh, state 3 via state 2. If you see here, 1 on epsilon moves to 2, 2 on 3B moves to 3. You have one more option. 1 on epsilon moves to 2, 2 on epsilon it moves to 4, and 4 on epsilon it moves to 3. So the end result is 3. So I'll include 3 as the output state. Any doubts here? Have you understood this transition part? Yes or no? Okay. So now the next two new states. We'll have delta closure of 1, 2, 4. 1 will give me 1 to 4. So from 2, do I have any transition on A? No. 2 to epsilon, we don't have any transition. So there is no way 3 will be included. You will have the same answer. Now the next one is delta closure of 1 to 4 on B. 1 to 4 on B. 1 on B is 3. Okay. 2 on B is 3. 4 on B is also 3. So you have the output as 3. Now what am I supposed to find? You have one more state through which I have to find for which I have to find the output. So we'll go ahead with the transition on 3. 3 on A. From 3 you have only one transition on B to itself. So 3 on A is a null set. Then we'll move ahead. 3 on B. 3 on B, you will have you have a loop to itself. So 3 on B is B. Fine. Now, which one is the final state? State 3 will act as the final state. So how many transitions do I have? I have 3 transitions. So we'll go ahead with insertion of the table. Fine. So you have state, the input symbols are A as well as B. The states are 1, 1, 2, 4, and 3. 1 on A, it moves to 1 to 4. And 1 on B, it moves to 3. I'm right. Similarly, 1 to 4 on A and B moves to the same set. What about 3? 3 moves to an null set on A and it moves to itself on B. Now tell me whether minimization is possible in this set. Is minimization possible for the given diagram? Yes, minimization is possible. So we'll try to minimize it. The first group will have state 1 and state 1, 2, 3. Sorry, 1, 2, 4. Right? Whereas the second group will have the first group will have 1 and 1, 2, 4. The second group will have 3. Now 1 and 1 to 4 are completely common. You can replace them. For our easy understanding, we'll put them as, I can also rename it as 1. So I'll take it as 1 itself. First group will have 1 and the second group will have 3. So what I'll do is I'll just delete this part. I'll just copy it and delete it. Okay. We'll just delete it. This will be an duplicate. Here I'll just have one, and you have the minimized DFA. Fine. So with this, we'll come to an end. Now for tomorrow's class, you will have